All right, everyone. Thanks for joining us this morning. My name is Matt Eckensweiler, and this is Karl Skene. And this workshop is on pixel mapping and performing with LEDs. We have a link up here for that contains a bunch of files. Carl's going to go around and just make sure what we want to do is open up a blank network and drag the LED mapping basic TOX into the network. And that's kind of where we're going to start off. We basically built this workshop following from Ben Voigt and Marcus Heckman's Intro to Touch Designer for Pixel Mapping. We're going to post a link for it afterwards. Definitely recommend going through it. It's a great resource. What we really wanted to highlight today was the pixel mapping and performing sections of this kind of LED interface that Karl and I have been designing. We've got some pre-built components that will kind of help streamline and get us to the pixel mapping and performing portion of the workshop. It's just a little background on me and Karl while everyone gets set up here. We've been working together for about 5 years. We've done a bunch of different stage installations, worked with projection mapping, lasers, traditional lighting, interactive components, and obviously LED. Kind of where Marcus and Ben's workshop left off was for more grid style configurations of LEDs. One of the things that we've kind of found throughout our experience is that sometimes you're using strips of different length. Sometimes you're using configurations that aren't in a simple grid. So one of the things we kind of wanted to develop was a way to easily move the LED strips around and adjust the mapping, fine-tune your mapping on site to make sure that what it looks like in Touch Designer is accurate to the physical structure. And so just kind of a look at the final product, the UI that Karl is using. Is it this one, Karl, or?
Yeah.
So you can see we've got a bunch of functionality built in here, several different pieces of content with parameters to control each of them. We've got blend modes for each of these layers. We've got presets for you can store and recall configurations of the different pieces of content you've created. And there's MIDI mapping, there's a sequencer, and it's all built into this UI. Kind of one of the big things we're going to focus on today are the custom components. So basically, all of the UI that you're seeing here are just parameters of custom components. So we didn't have to spend a lot of time building the sliders and creating this particular UI. It's just imported from the parameters of the component. And it's also a great way to build your network modular and to be able to take, for example, this ramp content and have it as a pre-made component and drag it into your session at any time or whenever you need it. So we're going to get started here, basically doing a quick overview of where Marcus and Ben left off. Just generally how to format the data to send to your DMX out. If we look at, I'm just going to pause this. We got a newcomer. So just to give you an idea of how the addressing works for LED strips, basically each pixel, in the case if we're in the RGB domain, will have three samples. And each of those samples will have an 8-bit color depth. So there's 256 values. And we mix the red, green, and blue together to get all the colors, all the wonderful colors. If we have 170 pixels, that adds up to 510 samples, which is basically the maximum number of samples we can output to a universe, or the maximum number of pixels. We don't have enough in the last two samples to fully control the last pixel. So 170 is the maximum amount of pixels you can send per universe. For DMX ArtNet protocol, we have 512 samples in a universe. In each subnet, you can hold 16 universe, and in each net, you can hold 16 subnets. And just to kind of visualize the way, and kind of relative to a channel in Touch Designer, you can see for each LED diode, we have our RGB values, and this is kind of how the addressing breaks down. So you have address sample 1, 2, 3 is RGB for the first pixel. Sample 4, 5, 6 is RGB for the second pixel. So basically, what we want to do in Touch Designer is we want to create the order of our data to match how it goes into the LED strip. So, and again, I'm going to go over this part quickly. It is in more detail in Marcus and Ben's lecture. And if we have time at the end of the class, we can kind of go back and explore this a little bit more. So just very quickly, basically we use a SOP to define each of the points. And every point is going to be related to a diode or a pixel on the LED strip. So we're using a copy SOP to create the configuration that we have in front of us. And if we look closely here, we can see the numbers of each point. So we can see it's starting at the bottom where the cable plugs into the LED strip, and it's counting upwards, and from 0 to 59, so we have 60 points on each strip. And we're going to use a SOP2 chop to convert this to channel information. So here we have for each point, we have our X, Y, and Z values broken down into 3 separate channels. The other set of information we need is to have our texture information also converted to channels. So we're going to use a top2 that's going to, basically it's referencing the UV sampling coordinates of our SOP. So basically for every point in our SOP, it's defining the RGB information. So what we have here in our top2 is red, green, and blue information for every pixel. And we need to get this all in a single channel to send out to our LED strip. So we're going to use a shuffle and sequence all samples. And basically what that does, it's going to put everything in order. So we have a red, green, and blue point for each pixel, all consecutively. And to split that up into separate outputs to send to separate universes, we're going to use another shuffle and split end samples. And we're going to split every 180 samples, which is, we've got 60 pixels, 3 samples per pixel. So every 180 samples, we're going to start a new channel. And this is going to send out to all our different universes. We've got a rename here and a math. The math is going to multiply the values from 0 to 1 to our 8-bit color space. So that's going to increase the value range to 255. And we have a routing table here which defines the net, subnet, and net address information for where each strip is sending. So essentially, each one of these lights is plugged into an output on our ArtNet controller. And the net, subnet, and universe of those outputs are defined in the box in the ArtNet controller. And we want to match those in the output of our routing table. So the IP address of our control box, which is on the ground over here, is 2.2.2.5. And the universes are 0 to 3, so we're using our first 4 outputs. And basically you can see what we're seeing in our top is being sent to the LED strips, which are in this configuration. So again, to really get into the details, you're going to want to reference the other tutorial for this. And so basically the next step at this point is to build a pre-visualizer so that we can see in Touch Designer what's happening. We can kind of take a leap of faith here that these things work, but we can build a pre-visualizer in Touch Designer that's going to show exactly where our LED strips are positioned on our texture operator.
Yeah.
Yeah. I mean, I'm sure everyone has lots of questions on this, but we're just going to move. We're going to kind of move forward to get into the pixel mapping and performing portions of it. I'm going to hand it over to Karl, and he's going to show us how to build the pixel previs.
Maybe just put the file on the USB and then you can pass it around for new people. Sure. That'd be basic. Okay. Okay, hi everybody. So, it can be useful to create a previs of our LEDs for one when we don't have LEDs on hand, and also say you're at a gig and you actually can't see the LEDs, which I've encountered a few times. Maybe there's no place in front of this stage where you can actually set up, so it can be nice to see them on your computer. So what we can do is let's create a new base. Yeah, so you can open up your Create dialog and select Base Component. And you can change the name to Previs. And inside Previs is where we will create this. And for this we will use instancing. And what instancing is taking a piece of geometry and making copies of it for every point of a map that we give it. And in this case, it will be a rectangle SOP. Sure. So you can put down a rectangle SOP inside the previs component. And this is going to be one of our LEDs that we're going to make copies of for all the points that we give it. So this rectangle, by default, the size is 1 by 1, so that's actually going to be way too big because it will fill the whole UV space. So let's change the size to 0.08 for the X and the Y. And we can plug the output of the rectangle SOP into a geometry component. And then you can go to the instancing page of the geometry component and turn instancing on. And that lights up this parameter, instance chop.sop. So we need to give it point positions. So we will plug those in from outside of the base. So let's put two chop inputs, two chop ins. So you can put one down and copy and paste. And you can go up one level, either by hitting the U key or zooming out. And in those two inputs we just created, we will plug in both our SOP to chop, which gets the point positions of our geometry that we have, representing our LED strips. So you can plug the output of the SOP to chop into one of the inputs of the previs. It doesn't matter which one. And we can also plug the top to chop output into the previs. And then we can go inside previs. And then we will put down a merge chop, and plug both of the inputs into the merge. And then we can add a null to this. And we can change the name to instance chans. So this is what we will use for our instancing. It has the point positions and the color information from outside. So on the geometry component, we can select it, and then we can drag the instance chans chop into the instance chop.sop parameter. And now we can give it all these 6 channels for the translate X, Y, Z. So you can click the arrow next to translate X and choose TX, and do the same for Y and Z, for TY and TZ. And then on the instance 2 page, we can input the color channels. So you can actually, you can click the arrow, or you can just type in RG and B under color mode for RG and B. And now in the geometry component, you can actually see that the rectangle is still too big. So let's put it to 0.008. Maybe 0.01. We also need to give the geometry a material. So if you go to the material page and choose constant, and then you can drag the constant onto the geometry component and choose material. And now we can render it. So we'll put down a render top. But it's not rendering it yet because we also need a camera. So for this, we will use a camera component. And we want to, we don't want to worry about perspective with this camera. We just want to fill, basically fill the whole render with our LEDs or our pixel map. So if you go to the view page, we can change projection to orthographic and change ortho width to 1. And so now the camera is centered around 0.00, but we want to center it on our 4 LED strips. So if we go to the X form page, we can translate it on the x-axis by 0.5 and on the y-axis by 0.5. So now our LEDs are filling the screen. Yep. The constant. Well, it's because, yeah, if we don't have the constant, the color just doesn't get. So we kind of need to start with a base color like that the colors kind of multiply with. So otherwise it's like they're multiplying with 0 and then it's just darkness. So yeah. Okay, so this render, we actually want to render this as a square, so we can go to the common page and let's render it at 720 by 720. And now, right away, we can start creating a UI. We'll definitely want to have our previs in the UI. So if we go up a level, we also want to see that previs in this previs component. So we'll go back into previs and attach an out top to the render. And by default, the common page already has the operator viewer set to ./out1, so that's why it just shows up. And so yeah, we can go up a level, and now we'll create another base and call it UI. Now what I actually meant to say was create a container, but what we can do is right-click and say change component type, and then choose container. Because UIs always have to live inside a container. And we need to make this our perform window operator, so what we can do is split our view, and on one side we can go up a level, and on our perform, we can select our perform window there and drag the UI onto window operator. And now if we go into perform mode with this, which is the symbol under file in the top left, we can see it's very small. So if we hit escape, we want to change the resolution of our UI. So let's set the width to 1280. Actually, sorry, 1920 by 1080. And then in the perform window parameters, we can take borders off. And we also want to change opening size to fill location. And that way, if you have a resolution that's not 1920 by 1080, it will just scale it to your resolution. We can close the perform window side. And now we want to go inside the UI container. And we can put down a op viewer component. And we can go to the look page, and we want to set our background top to be our previs. So we can split our view again. Go up a level on one side, and go into the LED mapping component. And go into the previs component. And we can drag the out one inside the previs onto the background top for the op viewer. Okay. Okay. So now if you go into perform mode, you should see your previs in the bottom left corner. And we'll come around and see if everybody has that. Okay, so I'm just going to go over how to get the UI into the perform window. Is that where you wanted me to take it from?
Yeah.
So we'll split our view. And in one side, we'll go inside project 1. And inside UI, we should have an op viewer. The background top should be set to our previs out 1. And the perform window should have project 1/UI as our window operator, with borders turned off and opening size set to fill. And what we can do to make our previs a little more noticeable is if we go to the look page on our op viewer, we can turn make a border around it. So for left, right, bottom, and top border, you can change them to border A. And another thing we can do to kind of see our LEDs, because say our content had a lot of darkness in it, like say we had this middle key was also black, and then we go into perform mode and we can't really see our whole strips anymore. And even maybe when we don't have any content running, we want to be able to see where they are so we can kind of design our content based on where our LEDs are. So it can be useful to composite this over a background. So inside the previs, we can put down a constant top. If we middle mouse click on color, we can change the values of red, green, and blue at the same time. So we can drag the 0.1 down to 0.4. And then we can composite these two together with an overtop. So we can right-click on the output of the out1 and choose overtop. And plug the constant 2 into the bottom input of the overtop. Sorry, what I meant to do was put that before the out, so I'm just going to delete out1 and then put an out1 after overtop. And on the over component, on the over top, we can change the fixed layer to input 1. Because when it's input 2, it uses the resolution of the second input, which is 256 by 256 by default, but we want to use this 720 by 720 resolution, so we'll change fixed layer to input 1. And we also want to be able to see our content in the background of this previs and be able to control the opacity of that. So we can, in between the over and out, we can right-click on the patch cable and choose Insert Operator. And we can choose an Add Top. And we also want to select the null top that's going into our top to chop. So we can split our view. And on one side will be in the LED mapping component, and on the other side will be in the previs. And on the previs side, we can put down a select top. And this is kind of like patching. Instead of connecting it with a patch cord, we can use a select top anywhere in our network, and then just drag this null onto the select top. And then we can choose relative. And then we can plug that into the bottom input of the add top. And now we see both our previs of the LEDs and the content that's feeding them at the same time. But to scale the opacity of that, we can insert a level top. So another way, other than right-clicking on the cable and choosing Insert Operator, we can also just right-click on the output of the select and choose a level top. So now, if we go into perform mode, it should look like this. So if I click the select top and look at the parameters, in the post page we have opacity. So we'll want to be able to control that, and also the color levels of our constant. Because sometimes we might want to see the background or the content, and sometimes we might just want to see the previs of the LEDs. So we can go up a level, and this previs component, we can start creating some custom parameters for it. So the way to create custom parameters is we can right-click on the component and choose Customize Component. we can give it a page name, and we'll call it previs. And now you can see this, if you have the previs base selected, that created a new page. So inside the previs page, we can create custom parameters for those, for the background and the content. So we can call the first one background. By default, it's a float, so that's what we want for this. So we can say add parameter. And we can also create a parameter for the opacity of the content, so we'll call that content.
Can you speak up a little bit for the far side there?
Yeah. We can close the component editor window. Actually, let's open it again because I want to give it a shortcut name. So if we right-click previs and say customize component and scroll down to the bottom and open up the shortcuts and tags. And we have parent shortcut and op shortcut. So parent shortcut is how we'll refer to this component anywhere inside the component. Op shortcut is how we'll refer to it anywhere outside the component. So for those custom parameters we created, we'll use those inside. But for both, we can give it the same name, previs. So now we can go inside previs. And another way to get those parameters is up in the address bar here. You can right-click on previs and choose parameters, and you'll get a floating parameter window. And to assign those parameters to where we want them, we can expand the parameter of background with the plus sign, and that shows us the parameter name. So yeah, we have the parameter name and the label name, and the parameter name is how it's referred to in scripts, and the label name is just how it shows up. So they can be different, and you can set that in that customize component window. But to assign this, we can actually just drag background onto color and choose reference. And now if you expand color, you can see that it created this reference here. Because we gave it the shortcut previs, it shows up as parent.previs.par.background. And now when we turn the background up, you can see it controlling. So we can do the same for the opacity of the content. So click the plus next to content and drag the parameter name content onto opacity and choose reference. So now, to make those parameters show up in our previs, or in our UI, we can go up 2 levels and into our UI. And we'll put down another component. This time it'll be a parameter component. And we want to set the operator to be the previs. So we can split our view, And on one side, we can go another way to, instead of like going up and inside networks all the time, you can just click on the slash after a base or a container, and it'll show you what's inside. So then you can just choose. In this case, we want to choose the LED mapping because that's where our previs is. And if we click on the slash after LED mapping, it'll show us all the components that are inside there. So now we want to drag the previs onto the operator parameter for the parameter component. So under page scope, we can choose the page that we created, previs. We can go to on the parameter page, we can turn on page names, and that shows the name at the top. On the look page, we can turn down the background alpha, and that just makes it look a little cooler. And we can change the height to be only as big as we need it to be for these two parameters. So you can drag height until it's just before it is too small that the scroll bar comes up. So 125. I dragged the previs component onto the parameter operator. So yeah, it's just from here onto here. Then you also need to make a couple changes. For page scope, you choose previs. That's the custom page we created. And also, I went to the look page and turned down background alpha to 0. And I turned on page names. On the parameter page. And I changed the height under layout to 125. And I also want the width to be the same as the op viewer that we made, which is 400. So you can change the width to 400. Okay, so now we have these two components. And if we go into perform mode, you can see they're on top of each other. So to fix that, we can actually group these together in a container. So if you put down a container component, and then you can select both of these, the op viewer and parameter, and cut and paste. Cut them, go inside container 1, and paste. So now they live inside this container. So we want the height of this container to be the total of the height of these two containers, which is 425. So let's set the height of this container to 425. And to put one on top of the other, you can go to the children page and align top to bottom. And that actually broke our reference because we put it inside of a new container. So if you change the parent 2 to parent 3, it'll come back. I went to the op viewer and I expanded the background top to show the reference. And if yours says parent 2, change it to parent 3. So now in our perform mode, we should see both the previs and our 2 parameters that we created. Go to the rectangle now. Okay, I'm just going to come around and get people up to speed. Okay, so now we'll start creating a custom component to generate some content. And I'll just show you from that finished project this box here. So right now it's turned off, but I'll turn it on and I'll turn off all the other layers. And you can see that the first LED is lit up. And we have these controls here for the color. There's a color picker and width and height. X position and Y position. So we can move it around and we can store and recall presets. I already have presets made for each LED. We can also chase through these presets by turning on chase. We can turn the transition up to transition between all our custom parameters that are stored in our presets. And there's also a blend mode, which can be add or multiply. So if I turn it to multiply and then turn on a layer underneath, you can see they get multiplied together. So let's start building this box component. So on the project 1 level, we can create a new base, and we'll call this one content. And then inside content, we'll create another base, and we'll call this one box. We can go inside box and then put down a rectangle top. And on the common page, we can change the resolution to 1280 by 1280. So the things we'll want to control are the size, X and Y, and the center X and Y positions, also the color. So those are the things we'll make custom parameters for. So if we right-click on the box up in the address bar where it says box, we can right-click and say Customize Component. And just as before, we can create a page name. We'll call it box. And we'll create parameters for the size, X and Y, and the position. So for the size X, we'll call it width. And height. So just remember, you have to click Add Parameter, and that will create the parameter. And we'll also create one for X position. Now, this is where I'll show you the difference between the parameter name and the label name. If I actually type X position with a space and position with a capital P, and then I click Add Parameter, you'll see that's how it created the label just as I typed it, but it automatically changes the parameter name to one word with the first letter being a capital and the rest all lowercase. And we can do the same for Y position. And those are all floats 0 to 1. And that's just what we want for these parameters. So now we can assign those to this rectangle top. If you click the plus next to size, and for the size X value, we can type in that shortcut parent dot box dot par dot width with a capital W. So the reason there is an error there is because I didn't give it a shortcut name. So if we go back to that Customize Component window, and if we scroll to the bottom and type in box with a capital B for parent shortcut, and we'll also type box for the op shortcut. And now we can highlight this reference and paste it, copy and paste it into size Y, and just change width to height. And under for center, we can paste it right in there for X and Y, and then expand the parameter, and we can change width to X position for center X. And Y position for center Y. And you can see they're all at 0, and that's why we don't see anything. But if we right-click on the box and choose parameters and turn width and height up to 1, we can see it there. We can connect this to an out top. We can go up a level and connect the box component to an out top. Now you'll see there's an output, top output on our content base. We can go inside LED mapping and create an in top. And we can just plug the output of the in top into our null 2. And then we can go up a level and just connect our content to our LED mapping. And now you can see our solid white rectangle is going to our previs. It's going to our LEDs and our previs. So we can move it around. And now to see those custom parameters on our UI, we can make another parameter component in our UI component. So we can put down another parameter component. And split our view. And on one side, we can go to content. And we can drag box onto the parameter component and choose operator relative. For page scope, we can choose box. Also turn on page names. We can turn the alpha to 0 again. We can bring the height down. We can leave it at 200 because we'll be adding a couple more parameters. Okay, so now our UI component has that parameter component we just created on top. So If we go to the children page of the UI container, we can change align to left to right. Now they're beside each other. But I actually want the box parameter to be on the other side. So right now the align order is 0 for both, but if we change the align order to 1 for the container 1, we can actually change this name to container 1 to previs. And change the align order to 1. And in the UI container, we can also turn up spacing. We'll put it to 100, and that puts some space between them. And now if I go into perform mode, I can control those parameters and see how they show up on the LEDs in the previs. So our X position and Y position are going from 0 to 1, but I actually want them to go from -5 to -0.5 to 0.5, and that way the rectangle can go to the left and all the way to the left and right. So if we go to our box component that we created inside content and customize component, because by default the floats go from 0 to 1, so if we select X position, we can change the range min to -0.5 and the max to 0.5. And we can do the same for the Y position. Okay, so before we get into creating presets for this, let's start creating another content component, and for this we'll start creating a ramp. So inside this content base, we'll create another component, another base, and we'll call this one ramp. And inside ramp base, we can put down a ramp top. We'll make it the same resolution as the rectangle, so 1280 by 1280. And I'll just show you in that finished project how the ramp is customized. So we can control the line width, number of lines, rotation of the lines. Right now the mirror is turned on, so if I turn that off, you can see they rotate all the way around. Soft edge, we can turn on and off. Circular, we can turn on and off. Not sure why it's not showing up right now, but oh yes. Thank you. So we can also control the movement of these lines with audio. So right now, it's getting controlled with audio. And in the bottom right, there's this little audio parameter component. So we can change that between file and device. So right now, it's set to device, so it's picking up the built-in mic. We can change how much of that is going to all our components, and then specifically to that ramp, there's also an audio gain here. Continuous, so there's kind of two different ways the audio can control the movement of these lines. Continuous just has them keep going outward or in one direction, and bounce has them return to the original position after the volume goes down. I can change audio to manual, and then I can control the speed manually. I can also change the width and height so that I can only put it on certain LEDs if I want. And yeah, and then there's presets here. If I have transition turned up, it'll smoothly transition between each preset. And the second ramp is exactly the same. So I'll go back to the other project, and we can start creating some of those custom parameters. First of all, I'll put down a null after the ramp. And if I go up a level on the common page of base, I'll change the op viewer to be null1 instead of out1. And you can also change, set the parent and global op shortcuts here on the common page instead of as I was doing it before in the customized component window. So for parent shortcut, we can say ramp. And since we'll eventually want to have more than one ramp that we'll refer to outside of the component, we'll call the op shortcut ramp1. So if we right-click on ramp in the address bar and say customize component, we can start creating some custom parameters. So we'll create a page called ramp. And for color, we can create a parameter called color and change the float to RGB. And then say add parameter. Some other things that we want are, we'll just make a few parameters now and then assign them later. Line width. For line width, it'll be a float. Number of lines, rotation. We'll do those for now. For number of lines, we'll just call it num lines. Add parameter, and then we'll change the label to number of lines. Rotation will be a float. And we'll start with those. So for color, if you click on the pink arrow in the bottom right corner of ramp, it shows the color values for our keys that we have. Right now we have 2 keys, so it shows 2 rows. So let's add 3 more keys. And you can see in the table it shows the R, G, and B values for each of those keys and the alpha, but we're not going to worry about that. We can select each key and then change the value. So for the middle key, key 3, we can turn value up. And for all the other keys, we can turn value to 0. Because we just want to have a single band of color that we control the movement of. And now we can attach this table to a null, because we're going to put some expressions in and evaluate it, and then now we can use this null as our ramp dat. So if you select ramp, you can see right now it's selected to that ramp1 keys table, but we can drag that new null onto the dat field. So now we'll put some expressions in here. So if we put this ramp1 keys in viewer active mode, we can, for the third key, for R, G, and B, we can put in the shortcut to the color parameter that we created. So for R, we can type in parent dot ramp dot par dot color R. Because if we bring up our ramp parameters and expand the color parameter, we can see that the parameter names are color R, color G, and color B. So we can copy that and paste it into row 3, column 2, and column 3. And then just change R to B for column 2 and G for column 2 and B for column 3. But to make those expressions work, we need to put an evaluate dat in between. So we can say insert operator and choose evaluate dat. And it's giving us an error. It says name, position, G, B, and A not defined. And that's because in this ramp keys, we actually need to tell, it's trying to evaluate these, so we need to tell Python that these are strings, so we can put quotes around each row header, column header, sorry. And now if we right-click on ramp in our address bar, bring up the parameters window, and if we choose a color, now that's controlling the third key in our ramp. Did you put quotes around the headers? Yes? So if you select ramp, at the top you see the DAT, and that's what it uses to get the color values for its keys. So by default, it's the ramp 1 keys, but we connected it to null, so you can just drag null 2 onto DAT 2, or onto DAT. And just so I can see this on my LEDs, I'm going to go up a level, and I'll put a composite top in between box 1 and out 1. And I also want to put an out after my null inside ramp. And I'll connect the output of ramp into the composite top. Okay, so to add these other custom parameters we created, for line width, we want to move these key 2 and key 3 forward and backward. So for that, we can, let's put down a constant chop. And we can type in that custom parameter for line width we made. So parent.ramp.par.line width. And we can connect this to a null. And we can copy this null and paste it. And we'll reference those nulls into our position of key 2 and 3. So key 2 will be null 3, chan 1. So the way you reference that is op followed by a pair of parentheses. Inside the parentheses, a pair of quotes. Inside the pair of quotes, the name of the operator. Null 2, did I say? Null 3. And after the parentheses, a pair of square brackets. Inside the square brackets, a pair of quotes. And that's where we specify the channel name, which is chan1. And then we can copy that, paste it into position 4, and change null 3 to null 4. And then if we open our ramp parameters, we're getting somewhere, but we need to make a couple more changes. So we want to have one of these nulls doing the opposite of the other one. So we can insert a math in between constant 1 and null 4. And on the range page of the math shop, we can change the to range to be the opposite. So 1 to 0. And for this to work properly, we need position 3 to be at 0.5. And instead of it going kind of wide to narrow back to wide, we want it to go from narrow to wide. So we can scale that with another math shop, this time after the constant 1. So if we right-click on the output of constant 1 and choose math, and for this range, we want it to go from 0.49 to 0. See, if I had said 0.5, it just disappears. So 0.49 gives us the thinnest line we can get. Because those are controlling the positions of these two keys here. So now when I turn this one parameter, it moves key 2 forward and key 3 backward. So that can control the width of this line. Do you have a math after your constant? Yeah. Do you have your range for the math after the constant to be like this? And then how about this math? And if you check out what's going on in the ramp when you move these parameters, is that, oh, I think maybe your key, yeah. So key 3 position has to be 0.5. Okay. So another thing we can do is control the rotation. The way we can do that is put transform top in between our ramp and the null 1. And if we just move this rotate parameter around, you can see it's rotating, but we have this empty space around it. So we can just scale it up on both x and y to 1.4. And then we can either export the rotation parameter from our ramp components onto rotate of the transform, or you can type it in parent.ramp.par.rotation. But we actually need to change the range of this rotation. Right now it's 0 to 1, so if we customize that component, another way to get to the customized components window is if you right-click on the eye icon and hold it down, and then you can just drag down and release on Customize Component, and the window pops up. So now we can select rotation, and we want to get a full rotation, so for range maximum we can change it to 360. And we can actually change the type to be an int instead of a float, because we don't need the decimal points in between. So now we can rotate the line around, change the width, but we also need to assign the number of lines here. And for that, we can assign it to the period. So we can expand the number of lines parameter and just drag num lines onto period and choose reference. But similarly with this, we don't want it to go all the way to 0 because then they all go away. So if we go back to the Customize Component window, and once again to do that little shortcut, you right-click. Sometimes it doesn't work though. So we can right-click on ramp in the address bar and choose Customize Component. And for the numLines parameter, we can change the range min to 0.01. So now we can make a custom parameter for that soft edge. Oh, actually, another thing we need to do, so right now the number of lines are lots of lines to one line, but we want it to be the reverse of that. Right, so this Python reference here, we can add math to it to kind of scale it how we want to. So if we actually subtract 1 from the parameter, or from 1. If we say 1 minus parameter.numLines, how did I do that? Just going to check my other project to see how I did that. So 1 minus the reference in brackets, and then after the brackets, we need to add 0.01. Here? That's a plus. Yeah. Okay. So to get these soft edge, or to change between a soft edge and a hard edge, we can use this interpolate notches parameter to change between step and linear. So let's create another custom parameter. And we'll call it soft edge. And we'll make this one a toggle switch. So we want to switch between step and linear. And a toggle switch, by default, switches between 0 and 1. And if we expand this interpolate notches parameter, we can see that when we switch between step and linear, the value changes between 0 and 1. So all we need to do is put that reference into our interpolate notches parameter. So we can just type it in, parent.ramp.par.softEdge. And now to get the mirror effect, we can put a mirror top after the transform top. So if we right-click transform and choose mirror, and we want to set rotate to 90 to mirror it along the x-axis. And basically, we want to be able to turn this mirror top on and off by bypassing it. So first, we will create a custom parameter. So if we right-click ramp and choose Customize Component, we can add another parameter called mirror. And this will be a toggle as well. And there's actually no parameter in the mirror top to bypass it, but we can use a Python expression to do that. So first we'll put our custom parameter into a constant chop. So we'll put down a constant chop. Sorry, a constant top. Yeah, constant chop, but I put down a top, so instead I'll put down a chop. And I'll put that shortcut in here, parent.ramp.par.mirror. And what we can do to get this mirror to turn it on and off is we can use a chop execute dat. So we can plug the output of the constant chop into a chop execute dat. And what the chop execute does is we can type in some scripts for what happens when this chop either goes from off to on, or what happens while it's on, or on to off, or while it's off, or on value change. So for this, we'll use value change. So we'll put it in viewer active mode. And we'll go to the return line under on value change, and we'll hit enter a couple times to give space for an expression here. And So when this changes, we want the value to control the bypass of the mirror. So we need to reference the, first we need to indent and reference the mirror, so we can say op, pair of parentheses, pair of quotes inside the parentheses, and then the name of the operator, mirror 1, I believe. And the way we can turn bypass on and off is we can just say dot bypass equals val, and val is the value of the channel that's the sample that's changing. You can see that here, the numeric value of the changed sample. So now if we bring up our ramp parameters, and turn mirror on and off, it actually turns the mirror off when it says on. So to change that, we can actually put a math after the constant, flip the range from 0 to 1 to 1 to 0. And now we need to, we'll put the math onto a null and use the null as the chop that the chop execute is evaluating. So drag null onto the chop parameter. So now when we click on mirror, looks like I made my range wrong here, so instead of 10 to 1, we want it to be 1 to 0. There we go. And now to where's that? To be able to scale the full ramp onto certain LED strips, we can add another transform top. And the same way that we controlled the rectangle, we can control the translate and scale of the X and Y axis. Also, we should save our work if you haven't yet. So we'll bring up the parameters again from the ramp component. And we'll add, actually we'll bring up the customize component editor. And we'll add some parameters for the width. That will be a float. Height. X position and Y position. And for the x position and y position, again, we need to change the range from negative 0.5 to 0.5. And then we can bring up our parameters, and we can just drag those onto the parameters of the new transform top we just made. So we can drag width to scale x, choose reference, drag height to scale y, and drag x position to translate x, and y position to translate y. And then we can turn our width and height up. And right now I'm compositing with the box, and it's set to multiply, so I can change multiply to add. Something funny is going on with my LED mapping here. Let's see. Okay. That's just because my box width was not all the way up. Okay, so let's add one more parameter. We want to be able to control the movement of these lines. So for that, we'll control the phase of the ramp top. So I'll go back into my content and inside ramp. Actually, I'll right-click on ramp and choose Customize Component. And we'll create a parameter called speed and make it a float. Inside ramp, we can put down a constant chop. And we'll plug that into a speed. And a speed into a null. And we'll select the null and turn it into viewer active mode. And then we'll select ramp. And we can export the null to the phase parameter. So you can just drag null onto phase and choose export. And now if you turn the value of the constant up, it makes the lines move forward. If you turn it into a negative value, it'll go backward. So we can put that speed parameter onto this constant value. So we can type in the shortcut parent.ramp.par.speed. And then if we go up a level, turn our speed up. but we also want it to go down. We could force it to go down, but we want to just set the range to a speed that we like. So we probably want to go a bit faster than that, maybe. So let's set our speed range to -2.5 to 2.5. So back in our customized component window, we can select speed and change the range min to -2.5, the max to 2.5. So if speed is 0, it's not moving. So another thing we'll want to do is control that speed with audio. But maybe before we get into audio, we can take a 5-minute break.
So one of the things we want to touch on today is another custom component, believe it or not, that we can use just to rotate and translate around a LED strip, just to make it easy. If the configuration of our LED strips isn't all straight up and down, if it's kind of a random pattern, or you're feeling really crazy when you're installing them. And of course, it's going to start with another customized component. So if we go back into our LED mapping box, kind of where all our DMX output pipeline exists, and we can make a base. And we can call it line. We can call it line 0. And get into our customization. And we can call our page translate. Add the page, and what properties do we want? It'd be nice to be able to change the length of the line. So let's add that parameter. Let's make our default 0.5 and our minimum range 0.1, just so it doesn't disappear. We can add the parameter points. That'll be an integer to help define how many LEDs are in the strip that we're using. And for default for this, let's go with 60. Max range will be 170 because that's the most pixels you can add to a single universe. And our minimum range is going to be 2. You need 2 points for a line, yeah. We can add a XYZ for the center point of our fixture. And our default, let's make 0.5, so it starts in the middle of our 0 to 1 UV range. And points. Oh, I'm adjusting the wrong thing here. So default for X, Y, and Z, we can make 0.5. Minimum 0, maximum 1. And of course, It'd also be pretty cool if we could spin this guy around. So we'll add a rotate as a float. And the parent shortcut for this guy, what we can call line. And let's right-click on and open up our parameters in a floating window, so they're handy for our referencing. And go inside the base. And we'll build a line SOP. And there's a couple of things pretty quickly we can reference. Our number of points. We can reference to number of points. Our length, we can reference to the B point on the line. And we can see now we've got a line control, points control. Let's add a transform for any translation and rotation. And we can drag our rotate onto the rotate of the z-axis in our transform. And I guess double checking our rotate should be able to go from 0 to 360. It's just updating that in the range of our rotate. So rotating, I don't really love how it's rotating around the starting point. So in our transform on the post page, we can adjust our post translate to origin. And what that's going to do is allow us to rotate around the center. Because of that, we're not going to be able to translate with this transform. It's always going to justify it to the center. So we'll add another transform. To use to reference our translate values for the x, y, and z center coordinates. And we can add an out to the end of this. So now we have a nice little custom operator that we can use to move our line around in UV space. If we want more than, if we want to add a couple here, we can copy and paste our lines and merge them together. And now you can see we can easily translate fairly easily. Translate our lines and have them exist. Kind of be able to fine-tune the position of the lines. One thing that's always helpful is to know where on the line is the input side, just to help troubleshooting if a pattern seems to be going through your LED strips backwards. So it would be nice if each line, if there was a label for which universe it was assigned to, and also where the starting point was. So let's add a text SOP back inside of our base. And let's make the text for that parent.digits. Let's parent in our Python expression, parent open bracket, close bracket, dot digits. And let's merge that with our line. Obviously, our text is far too big. And it's currently not located anywhere near our beginning point. So what we can do in the transform here is we can say let's translate the text to the x value of the 0.0 in the line. And the way we can call that, we're going to look at our operator out1. And we're going to look at the set of points. In that SOP. And we're going to look for the x point. Oh, sorry. In the set of points, we have to look for point 0. And we can also copy and paste that for our y parameter. And I like to toggle the compare flag on the merge, just so we can see both the line and the text. And to kind of, if we look at the information on this merge, you can see there's a lot more points than in the line. A bunch of points made up by the text. So we don't want any of that information to transfer to our LED mapping. So we'll create another out. And we'll basically have two outs. One to visualize where we can see the label on the LED strip, and one to send the DMX information. So we have one merge here that we're going to use for our DMX data. And we can have a separate merge here, which we could call merge viz, that we can use to see all of our line information. Is everyone up to speed on? So let's copy and paste this updated base. And we can connect all the first outputs to the merge, and all the second outputs to the merge viz. And I'm actually going to make 4 just to represent the LEDs that we have on the in front of us. 35 more minutes. Do you want to touch on audio?
Do we want to show, like, move the lights and angles and show that?
Yeah, sure. Maybe we can just let's move half of them up, and we'll use like the horizontal line to calibrate.
Now we show how to, now that we have a way to transform the line stops around, to show how we might map those to different configurations of the LED.
Well, basically, LED details works good if you're copying, if you're creating some kind of repeated grid system. So basically, the new base is if it's more of a if you can't really do it with a grid, or you have multiple different size LEDs, or things like that. Exactly. Yeah. Do you want to? It's already been. Okay. Yeah.
Just a way of like scaling all those together. I'll plug this merge into this transform sock, and then plug that transform sock into the null. And so now we have some angles here. So for each line, we can change the rotate. I'll translate this second one down with on the Z or on the Y-axis, and then over on the X. So basically, I'm just playing around with the rotate and center X and Y to get approximately how they look in real life.
And one kind of practical way, if you have your LED strips positioned and you want to make sure that the content is going to go through accurately, so we have a straight white line that's going through as the content. So you can kind of use that in real life. Karl, if you just want to to justify our two LED strips so that the white line is continuously straight across all of them. So you could use a grid, a bunch of vertical lines and a bunch of horizontal lines, and really lock in your content and to represent what's physically happening with the position.
Horizontal line?
Just like the white one going through. It's already going through. Just have to trim the LED strips up and down.
So I'll move the first line down. And the third line down. And I'll get some motion on that on the ramp. Okay, so now let's get some audio controlling that motion instead of manual. So I think I gave you an audio component in that link. Where's that link? Was there audio talks in those downloads? No. Okay, so let's. Yeah. So let's go to our project level of the network, and let's create a base. And we'll call this audio. Inside audio, we can put down an audio file in. And we'll also put an audio device in. The audio file in can go into an analyze. Wait. So the audio file in, we'll put it into a select chop, and we'll just select the first channel. So for channel names, we can say channel 1. And now we have a single channel for both. We'll plug those into a switch so that we can switch between them. And now we'll plug the switch into an analyze chop. And if we change the function to RMS power, that'll just give us the amplitude of our audio. And now we can easily use that to animate any parameter. But a couple other things we'll want to do to this audio signal is first control the lag. So we can put down a lag chop. And this will allow us to kind of create a smooth tail on the amplitude. So we can change the onset lag to 0. So that's the left parameter, because we want the audio to kind of hit right away, and then we can control the the post lag, kind of like contextually. And then we can also put that through a math chop to scale the amplitude. And then we'll put that through a null. And let's just create some custom parameters for those. So we can right-click audio, customize component. Parent shortcut, we'll call it audio. Page name will be audio as well. And for the parameters, we have, we'll make a toggle called source. And we'll make a float called lag. And a float called scale. Or we'll call it gain, actually. And we can put an out after the null. So we'll go into content, and we'll go into ramp. And where we have the speed controlling the phase, we can select the constant and speed, move them over a bit, and is that how we did that? We can put a switch before the null. And then we'll put a select chop. Oh. And with this, we'll select that audio, so we can split our view and go into project audio. And we'll drag the null onto the select. And now we can plug the select into the switch. And we'll go back into the ramp customize component window. And we'll create, this time, a menu parameter, and we'll call that audio manual. And then for the label, we'll call it audio/manual. And then for the switch, we can open up our ramp parameters and open up the audio manual parameter we created and drag that onto the index of the switch and choose reference. we need to actually give these label names some more specific names, so we can go back to the ramp customize component. And for audio manual, down at the bottom where it says menu labels, we can just delete all those, and we can just type audio space manual. We also need to flip the inputs on our switch. So if we select the switch, it shows the inputs at the bottom in the parameter window, and we can just move one above the other. And now we can switch between audio and manual movement of the lines. Yeah, I connected the audio manual parameter to the index of the switch. But we'll probably also want to scale the audio for the ramp, so we can put after the select, and I'll just change the name of the select to S audio, so I know what it is. And then I'll put that through a math. And I'll go ahead and add another custom parameter in the customize component editor. And we'll call it audio gain. And that will be a float. And then from my ramp parameters, I can drag audio gain onto the multiply parameter and choose reference. So now I can scale the audio controlling the lines. Another thing we can do is move all these parameters around in an order that maybe makes a little more sense. So if we go back to the customize component window, we can just drag them. So let's put the color, keep the color at the top, and then we'll put the audio stuff down to the bottom. And for audio manual, we'll put that over audio gain, and then we can add a section. So if you click section, and then if you have your parameter window open, you can see it just puts a line in between the parameters. So you can kind of organize it however you like. We'll put the toggles above the audio, so mirror and soft edge we can drag down. And the X position, Y position, and width and height we can put above the, actually we'll put them at the very bottom. And we'll put a section above width. Okay. So now that we have two pieces of content, if we go into our perform window, we can see, we might want to see both of them in the previs. So for that, we can make a couple of buttons. So we'll go into UI. And we'll make a container. And we'll call this texture buttons. And we'll want this to be the full height of our perform window, so we can change the height to 1080. We'll keep the width at 400. And then inside, we can create a button. And the reason that I want these to be buttons is because if you can see in the other project, these are actually buttons, and when I select them, it brings up another parameter component here that's specific to the one that's selected. So we'll change this button type to radio down. And we can give it a group label name, and we'll call it transport select. We can change the size to 200 by 200. And for this button, we'll use the box as our background top. So we can split the view and go into content on one side, go into box. But we want we also want to put a level in between here. To control the opacity, but we want to see in our button how it looks before any opacity, so we can insert a null between the rectangle and the level, and we'll use that null as our background top. So we can drag the null onto background top of the button. And now we see the box there, so we can actually just copy this button and paste it. And for this background top, we'll use the ramp. So we can go to content, inside ramp, and we'll use that null that we already made as the background top for that. And we can go up a level, and in this texture buttons base, we can change children alignment to top to bottom. And we can put some space between them. And now the way in this project, the way I made it so that when you click the button, it selects the parameter. If I go into UI here, you can see this container this component here is a select, and it selects each one of these containers So if you look at the select page, select panel is box controls. But if I click one of the other buttons, it changes the select panel to ramp controls. So inside of the buttons, there's a chop execute dat. And what that does is it just changes that what it says in the select panel to box controls for that button, or for ramp controls for the other one. And it also turns a border on and off so that you can kind of see that it's selected. Yeah. So we've got about 10 minutes left. Could maybe show you quickly how to set up audio MIDI mapping in case you want to have MIDI control of these custom parameters we made. So we can go into content and let's change one of these parameters, say the box. Say we want to also control the width of the box with a MIDI. So for that we can take either a MIDI in or a MIDI in map. If you've taken the time to create a map for your MIDI controller, then the values will kind of show up in a way that makes more sense. But I'm just going to grab my MIDI controller here. I got it. So if you go into dialogues, MIDI device mapper, you have some device. I'll just close all these and start fresh. So then you can say create new mapping. And if you look to input device, you can choose whatever controller you want, whatever one is hooked up. If you have created a MIDI in map, you can put it into your. If you go up a level from the project and go into local, and then go into MIDI and user devices. And this is where you would put any template you made, like from project to project. If, say, you made it in another project and you want to bring it into another one, you would put it there. But since there's not much time left, I'll just work with the basic MIDI in. So I need to set my paused. Okay, so let's say we wanted to change this control to the width of the custom parameter that we made. So we can put a chop execute dat. And we want to look at the name of the MIDI control. And then in on value change, we can say if indented, and then say if channel.name is equal to with two equals symbols, and then pair of quotes followed by a colon, and inside the quotes we can say the controller name. So CH2CTR50. CTRL 50. And then we can say the shortcut parameter to that parameter, which was parent.box.par.width equals val. And now when I turn this, it's controlling the width, but we need to scale it because it's going from 0 to 127, so we'll put it through a math. Range, we can change the from range to 127, and now it's scaled to 1. And now we can put that into a null and drag the null into the chop execute. And it looks like we have some, oh, I did this on the wrong one, but wrong project, because it's chasing right now, so if I turn chase off, and that's controlling it, so I can both use my custom parameters or the MIDI control, and they're in sync. Another thing you can do is use the bindings parameter. So if instead I had the width in the bindings, I can also change the value here and here. But if it's not in bindings, say you try to change the constant, it'll break it. But with bindings, they all stay in sync. So it's the purple square there, and I'll just do a fresh one. So I'll just put a constant chop. And I'll put my shortcut in the bindings field. So parent.box.par.width. Oh, I put it in the name instead of the value. Yeah, so I can control it with my MIDI controller, or with the constant, or with my custom parameter. And they all stay in sync. But if this was actually not in bindings and in reference, if I go to change the constant, then the width no longer controls it. So yeah, so right now I have it in reference. But if I go to control it manually, then the reference doesn't work anymore. It kind of breaks it, unless I click this again. But if it's in bindings, so if I cut this, paste it into bindings, now I can drag the constant, and it won't break it. And I can still use the MIDI or the custom parameter, and they all kind of. Yeah, the only thing is with references are a bit more flexible. So like, say this was in references again. I could say I wanted to scale that inside the reference. I could say times 0.5. And that'll work, but you can't do that with bindings. So I think in the future maybe we'll be able to, but Not yet.
You can't use any expressions in bindings, so.
Yeah. So yeah, does anyone have any questions?